Hey guys, my name is Cherno. Welcome back to another Cherno live stream. How's everyone doing today, this fine morning? It's like the coldest day in Melbourne. Well, this year for sure, but like I think it's the top of 7 degrees where I am. So, which is cold for an Australian winter. But how's everyone doing? I hope you're warmer than I am. Probably mostly summer for you guys in the Northern Hemisphere. Okay, so we have been obviously working on Hazel's renderer for a while now, and last stream I think we made some progress. I'm gonna try and run Hazel, and we're gonna see, I guess, where we're up to. But I think last stream we're basically kind of more or less done, like with the UI and with IMGUI and everything for now, and we are just gonna start working on actually getting the 3D renderer and like Hazel's main renderer working like properly with the new backends and everything. So the biggest job I think there is going to be that whole, like, the way that we manage resources or descriptors, because basically we need a way, obviously, to be like, I want to use this texture in this render pass, or this uniform buffer, you know, in this render pass, or even like in this specific material for that draw. And we used to do this using something called a Descriptor Set Manager, which I wrote for Renderer 2023. However, now I'm considering just nuking that entire thing and basically designing a system from scratch that will better fit this new renderer. So this might be a little bit of a designing session. I don't know yet. We're going to see how we go. I'm also going to try and keep it as simple as possible. Okay, so here's Hazel. This is where we're at. We have this like red. Get rid of this so it's a bit more clear. We have like this red color, and this is important because this red color is actually coming from the scene renderer now. So we have this like composite. We have like this compositing pass, which you can see sets the clear color to that color that we are seeing on the screen. So this is good because it's just showing us that we're actually going through, well, we are going through all of this code. We're creating like the proper Hazel render passes, and we are, I believe we're just doing a clear pass at the moment, which is basically running the pre-depth pass, which is just a depth buffer, and the composite pass, and it's actually doing an explicit clear on it. So it's definitely clearing the buffer, but it's empty, like it's not rendering any geometry. It's just doing a clear. And I think we enabled that by doing like an if false up here for the main pass. So we're not doing this yet. We're not doing all the main render passes, obviously, because they don't really work. But we are able to do a clear pass and display that final image in the viewport. So this is good. Like, this is a good, you know, improvement, I guess. It's nice to have that functionality inside Hazel now, like as in with the new renderer, that we can go through this, because it just shows that our code path is kind of complete in that sense, right? So, yeah, from here, it's like, oh yeah, so the big thing that we kind of wanted to do was 2D rendering. I haven't even finished my morning coffee. The big thing we wanted to do was 2D rendering. And by the big thing, I just mean like the first thing, right? That we want to do is 2D rendering, because that's just a little bit easier. Obviously, there's not that many render passes and everything, but we did discover last time that Renderer 2D also uses like render passes, which means that it also uses, like, you can see that it's setting this camera uniform buffer as like an input into the render pass, which does currently flow through that Descriptor Set Manager that I mentioned, meaning that it, you know, is... that doesn't work at the moment. We need to also make sure that this works. So by working on the 2D renderer first, it just simplifies everything massively, but it's still doing the same kind of stuff as the 3D renderer, but it's just like less moving parts to make sure that they work before we see a result. So that's why I want to work on the 2D renderer. So it might not sound very exciting, the 2D renderer, but believe me, once the 2D renderer actually works, the 3D renderer will basically work. Because it's already written. It's just that the wires aren't hooked up, right? Ilmaz says, or Ilmaz, I don't know. Been watching all the VODs. Hopefully we'll be able to catch up and watch some live after they're all uploaded. Yeah, I'm almost like, I've been publishing basically one a day when I can. Because I do take a little bit of time to export from Twitch. Then I export them from Twitch straight to YouTube. Then I have to trim the like stream starting soon segment off, which I just do using YouTube's video editor, but it takes like 4 hours to process that. And then once that's done, I feed the transcript into AI so I can get a stream summary and everything. So it takes a little bit of time, but it's very easy. Like, that's why I've been doing it so much. So I'm basically publishing one a day until that's caught up. So I think we're only 2 weeks behind now. And because I only do 2 streams a week, this week's like 1 stream, we catch up. So we should be there soon. Genesis.com says, hey, Mr. Cherno, I just wanted to say thank you for all the content you've posted. Even though I don't use C++, your teaching style and personality are probably the only reason I've been able to get into the software world. Thank you, bro. You're amazing. Thank you. What a nice comment. Appreciate you. And Camille says, hello, didn't know you were live. Somehow didn't get the notification for this. Well, you know, make sure you're following me, and then you've got notifications turned on, and hopefully you'll hopefully that will not happen again. Okay, so yeah, let's think about this whole design thing. And this is actually a good opportunity for those of you who are interested in Hazel's renderer design and how we like do resource management and all of that stuff. This is a good opportunity because we might be rewriting that whole system, and I'm definitely going to have to think about it because I don't have a design off the top of my head at all. To be honest, the only times I really work on Hazel these days are during these live streams. So you get to, and that includes design. Well, I mean, I think about Hazel outside of these live streams, but I don't sit down and draw diagrams or plan things outside of these live streams. So it's actually kind of nice in a way because you guys see what that's like. So basically, the goal is this, right? So I believe we're actually trying to draw lines here. Oh no, we're not at the moment, but if we go over here and we say that we want to show bounding boxes for all entities, well, here's our, because I was breakpointing this last stream to see whether or not it's actually even running that code. It is. We're not seeing anything on the screen though, and the reason why is because obviously if we want to draw like bounding boxes for all of our entities, right? So like, for example, here's a cube and here's its bounding box, which again, we're just trying to draw bounding boxes as an example. It could be anything, but obviously bounding boxes are made up of lines, and then it kind of lets us draw, you know, a box like this. And then we can see whether or not that's working, and that's our renderer 2D. And by the way, 2D renderer just means like the primitives that it's rendering are 2D. It doesn't mean that it's rendering them in 2D space, because first of all, there is no real 2D space. It's all kind of 3D. And second of all, it does let us draw even things like text in 3D space if we want, or it could be just in screen space, and then it's obviously not. So it can do both. But in order to draw this in a 3D world like this, it obviously needs the camera. And the camera, the way that it gets all the camera data into the shaders is by using, I got rid of it. Where is it? Is by basically taking in the uniform buffer, which contains the camera data, into the render pass. Now, why do we have this API where we can create a render pass, which is, as you might expect, it's like a render pass, right? It's like a context in which we have a specific render target and we do a whole bunch of rendering. Why do we have a render pass actually take in this input? Well, the reason why is because basically there are several ways that you can kind of segregate or define the lifetime of resources when you are drawing graphics, right? There are things that are like basically from most persistent to least persistent, or like you could also think of it as least frequently changing to most frequently changing. So for example, if I'm drawing a 3D object and it's like a box, it's a cube which has a texture on it, right? Then that texture will apply only to that cube. I mean, you might be drawing multiple versions of the cube, which is fine, but regardless, in which case they would be instanced anyway, so it doesn't matter. But if you're drawing a cube with a material, with a texture, that's gonna be per object, per draw call, right? So that's obviously a frequently changing resource, that texture. Now, what about the camera? Well, the camera, you have a camera that's defined for your entire scene. Like the camera does not change between each object that you draw, right? It's set at the beginning of the frame. This is your main camera, your main viewport. I'm going to render everything using that camera's point of view and all of its properties. So that's obviously a much more less frequently changing thing. Like in this case, it's kind of once per frame. I mean, I don't want to say once per frame because, you know, you could have multiple instances of a 2D renderer and they might be drawing into different areas, or like you might have whatever, like it might be more than once per frame, but it's once per frame per renderer is probably a better way to put it, or at least once per a context of lots of objects, right? So the camera would be here and then the material would be like down here. Now, even less frequently changing might be static renderer properties. So there might, and resources. So for example, for the 3D renderer, we have like a lookup table that we use for our BRDF. It's our kind of BRDF lookup table. That is a texture that we have that is basically makes math a little bit faster, because instead of calculating complex math inside the shader, we can just sample a pixel of this texture, and that's the result of the mathematical calculation. It's basically done offline and then stored in a texture so we can look it up. So that is an example of something that never ever changes. It's just in the shader. It's kind of, or it's on the GPU, that texture, and it's just a resource we need access to, but it does not change between frames at all. It's just there permanently. So that's something that's even less frequently changing. So the point of this is, as you are hopefully beginning to understand, we have a whole range of like different frequencies of how often we change resources. So the camera one that I'm talking about here, like we don't want to set this per object that we draw, right? Which in this case, obviously it's a 2D renderer, so we batch basically everything together, but still there are going to be separate draw calls for example, quads versus lines versus text, you know? And because there are different draw calls for all of those things, it makes more sense for us to just be like, okay, the camera is not part of the material or whatever, it's part of the actual render pass itself. It's an input into this render pass. That's the resource it's taking in. And that is basically translates to a descriptor set in Vulkan that will be bound at the beginning of this render pass, and it will stay bound until the end of the render pass. And is obviously bound like in the context of this pipeline, which is also part of the render pass. So hopefully that makes sense. So now we have to think about, okay, well, how do we actually, first of all, be aware of all of the resources that are present? Because that's the other thing, right? Like you could think of this many ways. This is the renderer 2D text. Let me just quickly see what shader that uses. So renderer 2D text is the name of the shader. So if I find that shader, this is what the GLSL code looks like for our shader. It's actually kind of complicated because we're using MSDF, so multi-signed distance field. So maybe let's select a simpler one. Not that it matters too much. They're all reasonably simple. Render 2D line is simpler. So this is really simple, right? This is the whole shader, both vertex and fragment stages. So you can see that like it has a couple inputs really. It's got two inputs basically. It's got this uniform camera, which is a uniform buffer, which has a map 4. And then it's also got push constants, which, you know, translate basically to constant buffers or root descriptors or whatever they're called in DirectX 12. I always forget. Root something, roots, I don't know, root something. Anyway, it's the same thing. So we have these kind of two inputs. The push constants we don't have to worry about. Push constants are always per draw anyway. You can dynamically set them during like command encoding, so that's fine. This is part of like a descriptor set. It's part of descriptor set 1, and you can see it's not descriptor set 0 because what we do in Hazel, which is actually, you know, I think it's basically the opposite of how most people do it, but our most frequently changing things are in set 0, and then from there it basically goes down, right? So set 0 is basically per draw. That's for things like materials. Set 1 is for things that are per render pass like this, and then set 2, and we also have 3. I don't really know how maybe if I have a look at the buffers thing, I'll see. So shadow data's in set 1. Yeah, so renderer data, for example, is in set 2. So these are all things that apply to a renderer frame. So not per render pass, because a renderer will have many, many render passes, but per renderer frame, that's in set 2. So this is still per frame data, that's why. And I think set 3 are things like the BRDF lookup table that I mentioned, which is like per ever. So, and that's how we do it, because I think Vulkan is, or GPU drivers are guaranteed to have at least 4 different descriptor sets. I think it's more like 8 these days, to be completely honest. Does the driver Vulkan optimize lower sets are most frequently actized? Yeah, I don't know, because the way that most people have done it, as far as I'm aware, is, maybe I'm wrong though, maybe I should do some research. Maybe you guys can do some research for me and let me know. But the way that I, and it's not too hard to change, right? Like obviously it's just a number, which set it is. So we could go back and change this and it wouldn't be that much effort. But I just, yeah, it just, to me, it just makes sense to do the closest, like the lowest numbers being the more frequently changing ones. But I don't know if the driver, I forget why people usually do the opposite. Anyway, so that's how this works, but you can see that this is a uniform buffer called camera. Now, the idea now is we need to create a bridge to like kind of bridge the connection between the shader and then like here I am in the renderer with an actual uniform buffer that I want to set into the into this render pass, like as in into this shader. So I have this uniform buffer here and I need to set it into the shader. So how do I create that bridge? Now, what happens in Hazel typically is let me back up a little bit. This is what it looks like when it's kind of at its core primitive level, meaning like in terms of code and functionality, what we're trying to do is get this data into here, right? That's what it looks like. But if we think about this in a little bit more of an abstract way, since this is not a per draw kind of object, you can think of it as this. We have a render pass here that is, for example, our line render pass. So this is a render pass called lines. Yeah, we're trying to draw lines. So we can think of this as like, okay, this render pass has certain inputs and it has certain outputs. Now, the output, you could say, for this really is just the buffer that it's writing to. So in other words, because it doesn't really, I don't think it just outputs a color into a color buffer, right? So this is basically just, hey, I'm outputting my color into some kind of texture. That's what happens here. That's our render target. But then the inputs are things that we need. So I'm not gonna worry about vertex buffers or index buffers because they actually get bound as part of the command buffer encoding, right? So they're not actually inputs into the shader directly in that sense. They're bound using their own commands. But in terms of resources, what we're binding are that camera and then also the transform, and the transform just lets us kind of add an, like, they're still batched together, but I don't actually know why we use a transform. I'm trying to remember. I don't know. I'll have to look at it. We'll have to have a look. But anyway, at the moment, and the transforms are push constant, so I'll kind of, write a PC here for push constant. But the camera is this kind of buffer, right? So this is how I like to think of it. We have a render pass, which this executes the shader. It takes in, some other things like vertex buffer, index buffer, obviously, to draw the actual geometry. It's got all the pipeline specification stuff, which just define, what the blending states are, what the primitive drawing stuff is, like all of that stuff. But in terms of resources, we have inputs and we have outputs. So we have this concept of like IO for a particular render pass. And then we're able to basically create this lines render pass with a particular shader. So we know that this maps to, let's just say lines.glsl. And then it, by reading that shader basically and having all of the code there, it's able to determine what the inputs and outputs actually are by itself. So we don't have to make sure that we definitely, that we kind of read the shader ourselves and then make sure that we set that input. Because it's aware of its inputs and outputs, the render pass system will actually tell us if we, for example, forget to set an input, or if we're trying to set an input that doesn't actually exist, because the way that we set them here is by name. So for example, I'm gonna have to clear this, but we have a camera, it's called camera, right? And because it's called camera, in the code, you can see we're using a string called camera to set it. Now, if we make a mistake here, if we misspell it, for example, or if we don't set it at all, it will tell us that that input doesn't exist in the case that we misspell it, or you didn't set an input. So obviously there is validation. That's actually what this is, validate. And you can see we have a core verify here, which just means that it's basically like an assert, but verify also triggers in release mode because this is a big deal, but not in distribution builds. We validate it to make sure that all of our inputs are actually set, and then we bake the actual render pass. And this same system of inputs and outputs works for materials as well. It's just obviously for materials, it's basically on a per draw level. And materials would have their own descriptor sets that get bound. So basically, at the moment, the system is kind of simple. Like I'm not just explaining this for your benefit, I'm actually also explaining this for my benefit because I need to talk myself through how this works and try and maybe simplify it or come up with something that's gonna work for this new renderer. I really like this system. I think it's really good. What Bake does, by the way, is, I should probably look at it just to make sure, but Bake basically will take in all of these inputs and immediately create like VK write descriptors probably, and update the descriptor sets with those resources bound where needed. And it'll probably do that per frame in flight as well, because for example, this is a uniform buffer set, which means that it's got, if there's 3 frames in flight, it's actually got 3 uniform buffers. So it needs to also create a descriptor set, like a VK descriptor set for each frame in flight, which has the appropriate buffer bound to that descriptor set. So that's what Bake does. It kind of does all that for you so that when it's time to render, you know, you're not actually going through and updating descriptor sets, because you don't want to be doing that, especially if you don't have to, because it kind of defined up front. Because generally you want to cache that stuff. You want to just be like, okay, I want to draw this object with this texture. When it's time to actually render it frame to frame, obviously that texture is not changing. It's not, you're not rebinding your texture every frame. So you might as well just have a descriptor set ready to go. With that, and a descriptor set is a set of descriptors, and each descriptor would be like a buffer, texture, all that stuff, right? Okay, so basically we just need to make sure that this render pass / resource manager system is just aware of what the shader requires. I actually wouldn't be opposed to writing this again from the ground up, but I think it'll probably be more work than if we just repurpose the existing system. But it seems not too bad. And who knows, maybe we'll find some bugs. So let's begin. So what happens is when we try and set inputs or validate, I'm pretty sure all this does is it goes to this descriptor set manager. I don't know why there's no like line breaks here. You can see it's just kind of a wrapper around this quite a bit. Yeah, I don't know why there are no line breaks. Yeah, and then it's gonna, yeah, okay, cool. And then validate, for example, will go through and actually, at the moment, you can see I'm skipping all of it, but it's gonna go through here and make sure that everything's done correctly. So there's a little bit of code here. It's like 700 lines. This is just descriptor set manager. I'll keep it called descriptor set manager for now. I'll probably rename it to something like renderer resource manager, or I don't know what to rename it to. We'll think about it when it's done. And it's a struct as well for some reason, which is fine. I guess because of all these things are public. But anyway, we're gonna look at the design of this because this is like the heart of the way that the renderer manages resources. So the shader is the source of truth for inputs. Yeah, we decided to make it that way. The reason why is because I see the shaders as data, right? They're not fixed in the actual code. And so it's kind of like you get to outline the, like what a render pass is basically, or what a render pass is by the shader inputs. And then it's up to the engine to basically set everything for that. Now in the future, we do want to make this somewhat dynamic. And by dynamic, I just mean that as I showed you guys, the fact that we have this like render pass, for example, that's our lines, and it's got all these inputs, we want to be able to wire up the inputs basically using the editor UI. So you'd have like a node graph of all of this. And then obviously you have like all of these things, like here's a uniform buffer set for the camera. I'm going to wire this in specifically like that. And then this will be stored like in YAML or JSON or some kind of binary format for runtime probably. And it will actually dynamically create this for you. And the reason why this is important is because it wouldn't really change much for the core renderer, I would think, but it allows users of Hazel to basically create their own shaders with their own render passes and wire everything up. Because another thing that often happens is there'll be an output from like, you know, a pass. For example, the pre-depth pass does a depth pass of all the opaque objects in the entire scene. So that output depth buffer, you may want to feed in to a custom shader that you've written, or I mean, it will get fed into various other Hazel render passes, for example, and you can wire all that up yourself, you know, visually. So that's something I really want to do, but again, it's kind of low priority because the core renderer doesn't need it. And obviously, if you have access to the C++ code, you don't really need any of this. You can just write some C++ code. And in fact, on my Patreon, I actually have videos showing how to write a custom render pass for Hazel. So meaning like a custom shader that does something and fits in with the rest of the render passes. I did that probably a couple of years ago, and it is still valid. It'll probably still be valid even after this new renderer because that high level API is not changing as far as I'm aware. So anyway, yeah, that's how the system works. Now you can see that this descriptor set manager has naughty things in it, such as VK descriptor pool, which it's not going to have anymore because it's not going to be Vulkan specific. And also, where are we storing this descriptor set manager? Yeah, it's actually in platform Vulkan, which is wrong because it's not going to be Vulkan specific anymore. So if we go through this, I'll do like a little bit of a code review. So move these enum structs to a non-API specific place. Well, this is now a non-API specific place, which is nice. Maybe rename from render pass to descriptor or something more generic. All right. Because these are also used for compute and materials. So yeah, we'll get to, so this is basically done, as in I haven't actually moved it, but it will not be Vulkan specific anymore. And then yeah, yeah, I agree. This shouldn't be render pass as the resource type or anything because obviously it's also for materials which are not render passes. Then we have render pass input, which takes in all of these things. Basically a render pass input. This is not good as well. We're going back to like the root class because we don't have a common class for all these things, so I don't like the fact that this can just take in any ref counted object. That's a bit wrong. And then we have one of these resource types which are here. And then why do we really discriminate between resource type and input type? I see. I mean, I still think it's a bit weird. Yeah, okay, we'll revisit this. This is like more of a primitive thing, whereas this is more of a high level thing. Okay, so, and then what do we do here? So, because this is just, the idea here is just to store basically all of these inputs inside here. And I think the thing is, this is supposed to represent one input, but it has a vector, which is not good. I'm gonna change this to be a static array, I think, which is kind of like a stack array, but it behaves like a vector. And the reason why is because this, it's because of arrays, right? So this is a single input, but you might have an array of 30 textures as an input, yeah? So in the shader code, that would look like, if I find that renderer 2D text thing, which has a, well, actually, I don't have to show an example. I have to write an example. Here's an example that already exists. So for example, for drawing text, we have an array of 32 potential sampler 2Ds, meaning textures, that represent our font atlases. So you can see that because there's 32 here, most of them would be unset, but as in they would be set to like a white texture and unused, but these are all here, and this should probably be in set 1 or something. Or actually, maybe this is per draw. Anyway, because this exists, we need to have a vector here because we might have more than one. Even though it's a single input, it could have more than one texture in it, for example. Okay, so we have all of this stuff, and then we have set, which just does the same thing as the constructor. It's called set. Sure. I don't know if index equals 0 is a good default argument, because maybe you should be explicit with how you set it. Otherwise, it's a bit unsure, but whatever. So this is, again, just setting data. So what I'm going to do here is, because these are just refs anyway, I'm actually going to begin changing this. So this is going to become an NVRHI static vector, which is going to behave the exact same way, except it's going to have a max elements of 32, which this should probably be defined somewhere else. But nevertheless, we're just going to do that. And this is just going to avoid, first of all, like, I don't think there'll be much reallocation, but it's just going to keep the memory a little bit less indirect. And that's why I want to do that. So we'll go ahead and change this up. Now, I guess it would be good to define. So let's do const expr. What does it want for this? I guess it doesn't matter. You want 32T. Max. Max array elements or something. Well, actually, I guess if we're going down this route, I guess I can do it here. Let's put it up here. And we'll call it input array. We'll set it to this. This just makes it a little bit easier, because when we come over here, we don't have to retype like this, you know, with max elements or whatever every time. Instead, we just do that. Now, the thing is, I don't know if it has a constructor that immediately lets you create one thing, but I feel like it doesn't need it. I feel like you can just do that. And that should work, yeah. I don't know if I want to call it input array, but that's basically what it is. Okay. So that's all that done. Is compatible input. We're gonna have to rewrite. And then obviously all of these conversions we have to rewrite. But otherwise, yeah, we just have a render pass input declaration. Set binding count. Nah, that's all correct. I don't know why we have to have this. Like, I feel like the shader system might provide something similar. But I guess we'll see. And then Descriptor Set Manager Specification. I don't know if looking at all these structures is a good idea. It's probably better to just actually dive into the code and see how it works, and then we'll find all these friends along the way. But let me quickly just check this. So Descriptor Set Manager Specification. Yeah, so this is actually the specification for this class. Okay, cool. So let's read this. Input resources map of set to binding to resource. Invalidated input resources will attempt to be assigned on a render a begin pass. This is useful for resources that may not exist at render pass creation, but will be present during actual rendering. Yeah, this is a little bit annoying. I remember. Render a begin pass, I think, calls like prepare for rendering or something like that. What does it? Because there are scenarios in which things might not exist at the time of you outlining the specification of a render pass. Yeah, so the resource, like you might have, yeah, but, okay. So basically you might have the specification of a resource, but GPU side, it doesn't exist yet. So in other words, you can't create a VK descriptor set for it yet, but you can create all the specification for it and then actually bind it to an actual image on the GPU, for example, at render time. So that's not ideal because it means, well, it's fine, I guess, but it does mean we have to check over everything before we render. But I don't know if there's a way around it because there are just some things that are kind of lazy in that sense. Like they don't just exist immediately. So I'm not sure about that. You can see we also only support arrays for texture 2Ds, which that should probably be flushed out. Shock 2K5, Shock 2005. Thank you for the Prime sub, appreciate the support. Yeah, so I don't know, like, about this. This is, but I guess that's why we have this whole invalidating input resources thing and all of that, so I don't really know. I guess it's okay. Let me quickly, so in terms of the actual code that this will translate to, so obviously what we used to do in the CVP code is, a lot of this is actually has nothing to do with Vulkan. A lot of it is just sorting out what inputs a render pass requires, at least ones that are for the whole render pass. Thanks for what you do. Your Java game tutorial really helped me back in school. You are welcome. That was a while ago, that Java game tutorial. Unless you watched it recently. But yeah, that was like a decade ago, more. Damn. Okay, so what was I saying? Yeah, so it's just setting up stuff here. I mean, we still do things like this descriptor type, which is specifically this, which I don't... Oh, but that's for write descriptors. Okay, that's fine. So yeah, so what we do is we basically... in the shader descriptor, which this is very much Vulkan specific still, but we store, for example, these VK write descriptor sets, which this is basically the kind of skeleton in a way. I can actually just change this to be NVRHI stuff, but it's like a VK write descriptor set is basically what you're updating the GPU descriptor to be. So basically it's just, here is, you know, set 1 binding 3 that points to this actual image that's on the GPU, or this buffer, or whatever resource you're trying to bind, right? So this is actually the most crucial step because it's what binds like an input or just like an index to an actual concrete resource. But what we do is we create them without the resource because we don't know what resource we're binding yet, but we just create the skeleton for it so that we can then just simply set the resource and we don't have to worry about all the other metadata when we have the resource, and then we just, you know, set the resource as soon as we have it and everything else is done. And then we can call VK update, you know, descriptor sets over here. You can see with like the right descriptors. And then if we have a look at the rest of this, I mean, this is true all the time, apparently, but default resources, we'll just create default resources for everything. So in other words, even if we don't have something set, but for example, it is a texture, we just set it to a white texture. Or if it's a cube map or whatever, we set it to a black cube map. And the reason why is because it means that we don't have to go through and fill in everything if we don't need to. So for example, in that text shader, you can see we have 32 font atlases, but we might only want to set 3 of them or whatever. And because this isn't like a bindless resources, null resources scenario, which you can do these days, but I don't think you could initially. You have to, like, the practice is basically, if you have 32 textures in your shader, but you only need 2, but you've created room for 32, the rest of them have to be set to like a 1 by 1 pixel white texture, for example. And it's usually white so that you can still multiply with it, because white is kind of unset. Because the color is 1, it's white. It means that if you multiply like a vec4 color with that texture, you'll just get the vec4 color because multiplying by 1 does nothing. Whereas if you, you know, had a black one, then multiplying by 0 would just get rid of the color, just make it black. So that's why this is, for example, white and not black. Anyway, going through the rest of this. Yeah, so this right descriptor map that we actually have here. So this doesn't exactly need to exist anymore. I'm getting to the point where I actually need to look at how we set resources and we create these. They're called binding sets in NVRHI. And a good place to look at that is probably the IMGUI renderer, since that is what does that. Here it is, get binding set for the actual font texture. I mean, it's basically for the font texture. It does separate the texture and the sampler. I don't know if it needs to. What's also weird is that, I forgot about this, but when you have, I think, separate textures and samplers in HLSL, or actually even in, no, I gotta look at how Vulkan does this. Because Vulkan can have like these combined image samplers, whereas here a lot of the time we have, here, like in HLSL, it can be split, but in Vulkan, it's usually combined. And that's why, for example, in our IMGUI HLSL shader, like we had to basically say that the sample is actually a binding 128. So I don't know if we need to set the binding to something else, like for samplers. Here we don't. Like here, they're actually still set to 0 though, which is odd. Yeah, it's super weird. The reason why is because it actually gets internally, it actually adds 128 to this just because it's a sampler. So we, this is going to be interesting because out of all these binding set items, I don't know if there's a combined one here. Doesn't look like there is. So either, well, yeah, we can't add that, but yeah, I don't know. We'll have to think about this. And then, yeah, I mean, this is very easy though. We just have the description, the binding description, all of these bindings here. Now, in terms of the types though, maybe we can use NVRHI types for all of these things. So, and then we just create the binding set, and that's obviously from the binding layout. So we definitely need the binding layout, which I believe we just get from the shader, right? So, oh no, well, in this case, we create it. Yeah, see, so the shader should probably create this for us, in the sense that because it's actually kind of similar to what we were doing already in the shader, but just using Vulkan directly. And so once it has that, so we go through here, we get shader descriptor sets, and shader descriptor sets are a Hazel representation of everything, I guess. And this has all the metadata that we care about. So I guess that's still important to actually keep. And obviously this is, we're not going to probably change this because it's what gets serialized, although we do serialize stuff like that directly, which is a bit annoying. Yeah, so we go through. And this internally has these right descriptor sets, which this probably comes from like the shader compiler. Or maybe not, maybe from, yeah, the whole shader system's gonna be not that fun, I think, to rewrite. I don't know if this part is actually working, because it looks like it's turned off. Create descriptors doesn't work. Okay, yeah. So this what I guess what this is doing is, yeah, this, I think we probably have to start by rewriting all of this, because oh, actually we are kind of doing it here already. Lol, I think I've already done it. That's the best when you When you're like, ah, I gotta do all this tedious work, and then you're like, actually, past me already did it. So we do have these descriptor set layouts already, which are binding layouts. So we full on have binding layouts. Huh. We call them descriptor set layouts. That's good. I mean, I don't know if that's... Yeah, I mean, it looks like it's kind of similar to this. I don't know if it... I guess it's implemented for everything. There's just a lot of Vulkan boilerplate. And this doesn't need to exist anymore anyway. And descriptor pools don't need to exist. I think that's fine, actually. I'll just change this to get graphics device now that that exists. A bit better. And this should actually be device handle. Not a huge difference, but yeah. Binding layout description has all the bindings in it. What about for various sets? It's stored per set though. Okay. So then... I see. It goes through that. Yeah, so write descriptors I probably will get rid of or we won't use. We just won't use. Yeah, we don't need them. That's actually kind of nice. Okay, so then what are we doing here? We've got the shaded descriptor sets, which we've already used to create the descriptor set layout. So we've actually got the descriptor set layouts as well, which we need because I guess what we're trying to create is, well, we've already got the binding layout and everything. So what are we trying to create? We just need the binding layout to create this set, I believe. So get binding set, you can see, needs the binding layout. But we're just trying to create this binding set. But this is something that has to happen when we have the actual resource. And then we can cache it. So that's also fine. So I guess we can start that pretty much immediately here, right? And how do we actually set a texture into, so it's just an NVRHI texture and we set it into the binding set item. Okay, sure. But this is just setting it into this render pass input. Yeah, right, okay. And then when we do, there's no prepare, there's validate. Validate, I believe, okay, we need to make sure the validate works. And then bake. Bake is what actually does it. And this is where we go through all the input resources and we're gonna have to actually create those binding sets that I mentioned. But that's kind of it. Okay, good. This is easy. So let's make sure that we do a validate here. Otherwise it doesn't work. None of this stuff I care about. This, from here onwards, I'm gonna copy and then strip. So, I guess so M descriptor sets. These are basically gonna become, I think, our binding sets. Yeah, so this will be NVRHI binding set handle. And I guess we should rename them to binding sets. If the size is less than 1, then we add 1. And then within it, we have a descriptor set that we clear because it's a vector of vectors. Okay, sure. Okay, so we're going through all the input resources. Descriptor count in set. Oh, look, we've already translated some of this somehow. Oh, that's kind of cool. Alloc info, descriptor pool. None of this needs to happen anymore, I don't think. And then we in place back. It wants so it actually wants a set already, but we haven't really created it yet, have we? And we're in frame index 0. Why does it want one immediately? Oh, hang on. Binding sets for a frame minute. But isn't that a vector? What was it in placing back? Descriptor set. That's a VK descriptor set. Huh. But... oh, it's in placing back, sorry, into the vector A. Yeah. I think we can just do this later. I'll keep it as DSL, I guess, for now, so I don't get lost. Image info storage. So this is because we need to like pre-allocate some space, I think, for images. Okay, let's just handle one case at a time, starting with uniform buffer. So the right descriptor sets, stored right descriptor map. So I think none of this exists anymore. And this is basically what our binding set description is. I'll call it that. And then obviously we need to set the bindings for it, which is a vector. But it doesn't seem to happen immediately. This is a little bit confusing. Because yeah, because it's trying to go through and actually find the exact resources here. This is bake, so this does not happen every frame. This just happens when you bake the render pass, which is usually once you create it and set all the inputs. So yeah, so we just need to get the input, which is already kind of in the right format anyway. Like this is kind of correct. And then from there, it basically wants the handle. And I guess we just can set that immediately into the binding set description. Is that right? So if we do bindings and then we can do something like pushback, which I might optimize a bit later, I think we can just do, so for a uniform buffer, it would be, probably just constant buffer. So slot. So slot is the binding for it, which we should have in input dot, or do we have it? Where do we have it? Or is it the index? Okay, come back to that. And then the buffer will be buffer get handle or whatever. At least it should be. No, we don't even have a way to get the handle. Lol. Do we have that for storage buffers? Yeah, so I need to know what input it is, like as in input resources, render pass input. Set to binding to, oh, right. So it'll be set. Oh. Yeah, okay. So binding is what it is. Okay, so all of this goes away. And we have that now set. And it doesn't matter what the order is because it actually takes in binding, I assume. Now it wants a buffer range. No, that's actually set. as a default parameter. So defer if resource doesn't exist. Yeah, so this is a bit questionable. So it adds it to invalidated input resources instead, right? If it doesn't exist. So what that would look like, basically, is if buffer get handle is null. The thing is, at the moment, it always exists because we create it immediately. So I feel like that's not even something that I'll revisit this whole thing, right? So yeah, I'll have to have a look at that. Okay, with uniform buffer set, we actually go through the frame index. So here it's like we specifically look at the frame index and we set that. So this is going to be a little bit different. Now, I don't think we need to do as uniform buffer. Ah, I see. That's why we do that. Yeah, because this is, I mean, it worked anyway, but it's a ref counted object. Because remember, these inputs are not that. These render pass inputs, input resources are, they just have ref counted, which not a, I'll change the hierarchy probably a bit later. Maybe. Okay, that's why we need to do this as, but it seems to work anyway. What's your editor's theme? It's based on Grovebox, but it's like a custom theme. I'm probably going to release it at some point, but I've been saying that for years, so sorry. One day, when I get around to it. Okay, so yeah, this is just, so where are we getting this from? Buffer get frame index, and then basically get handle, I think is the idea. And then that is something that we can, yeah, this, oh, I don't know about that. Yeah, so this is our actual buffer. And this goes into, I guess that's it. You just push it back into here. There's also a constant buffer. It's just a bit more indirect. It's just, it needs to get the current buffer for the current frame index instead of directly getting it. That's all. That's the only difference, I think. And this is, storing it is interesting. I don't know, because it's obviously stored anyway. I don't know. We'll have to have a look at what on earth I was thinking. This I'm just going to get rid of for now, because we've left it up here and I'll investigate it. Okay, storage buffers, same situation. This is pretty easy. Except instead of a constant buffer, it would be probably a unordered access raw buffer, I'm guessing. I don't know. We'll get rid of this. So yeah, pretty easy stuff. Converting this. Replace frame 0 with current frame and fly. That's already done. This is the same as the uniform buffer set. Except it's a storage buffer set. It's literally exactly the same except for this. Texture 2D. So, image info storage. Why do we do that? Where is that used later? It doesn't look like it is. This is bizarre. Let's get rid of that for now. That's so weird. We'll come back to it if we need to, but I just don't remember why. Okay, so it's for an array as well. So I guess, all right. So no. I think it's used right here because it needs an array of it. Okay, that makes sense. Never mind. I thought it was deferring it, but it's not. So I guess the idea is we fill this image info storage with, instead of VK descriptor image info, it's a vector of vectors, but anyway, whatever, it'll be something else. This will be a vector of NVRHI texture handle. And so we're basically adding texture get handle into here. So we have an array of all of them because I don't really know how to set arrays in NVRHI like that, but so like, because it just wants one. So how do you set an array though? Binding set item. Array element. Ah, okay. So you have to size property of the binding layout item. Sure. I guess it still wants individual ones, which would kind of mean, or does it? You just have a separate binding set item for each of them, I guess. Interesting. I think I got that right. So that would actually mean that instead of basically doing this, you can just do bindings push back. And then we would do a texture SRV. Binding would be binding. Texture get handle will be the handle. And then I don't know if we need to set anything else because we don't elsewhere, but we need to make sure that array element is set to I is basically the important thing, and then we push it back. So that means we don't need any of this image info storage because we just iterate through it here. Okay. Cool. And then I guess it gets its own entry into here. Now else what? Oh, if input size is not. Oh, well actually it doesn't matter because it's the same code path for both. We can just set the array element to 0, which it already is. And then all of this disappears. So actually this is massively more simplified, which is nice. So texture cubes, have we gotten those to work? I don't know, that's a good point. Yeah, I'm not sure. Image 2D, yeah, this whole thing. On here, it's a render resource. Why? I don't know. Because it could be either a texture or a. I guess because you can set either a texture or a thing. Okay, get descriptor info is dumb. Although, actually, resource descriptor info, like, what does it actually give you? A struct, which has your image handle in it, which I guess is what we want. Yeah, so I guess this would work. So you get image info, and then from there you can get your image handle. And then I guess you put it into here, as usual. And this I'm very confused about, but that won't happen, I don't think, but we'll see. Is that it? That was kind of brief. Now, write descriptors is invalidated. Oh, yeah, okay. So that shouldn't really exist. And then we do update descriptor. Yeah, so this basically all of this is just kind of, I guess we just kind of do if that. Oh, right, it's per, wait, what? Where do we create that? Binding set description. So that should be per frame index, not per binding. Yeah. So, I guess if binding set description.bindings.empty is false, then we're going to go ahead and create this. So I don't know why this is written like this actually. I don't know if that should just be at the top, probably. Where's that binding layout handle? And then that gets us a binding set handle, which where do we store that? Right, that would have been the equivalent of a descriptor set, which we stored where? Allocate descriptor set. We stored it in M descriptor sets. So that's the thing that I renamed, right, to binding thingies. Did I? Or did I just get rid of it? What? Oh, here it is. Why is it public? Oh, we don't need that anymore. Okay, cool. So, how did this used to work? So, yeah, that whole story. Do we still do that? Yeah, so we've done it in place back. But what about per frame in flight? We haven't done that, have we? Oh, that's what this was. So binding sets, frame index, in place back. This just gives us room so that we can later basically just be like... so frame index is actually the second thing, apparently. Yeah, because we're in a frame index. Oh, no, binding sets at frame index. Wait, what? So, yeah, it's frame to set. Would it be? I guess so. Yes. But how does that work here? It doesn't. I think we have to do... Oh, it does. Descriptor set count. I thought that was different. Descriptor set count. That's... Oh, I guess that's count of individual descriptor sets, not overall. Yeah, okay, sure. Frame index and place back. Okay, cool. So basically that just means we do frame index and set. equals that. So we now have a binding set. I can delete all this. We now have a binding set for our current frame index and our current set, hopefully with the resources set appropriately. That's it. Really, really simple. Now that you don't have to manage everything yourself as well in Vulkan. And then that's the old code, which is gone. Now, invalidate and update. That's what it was. That's the prepare thing that I was talking about. Again, I don't really know if this is necessary. So what this does is it goes through everything and just checks to see if it's present or not. It basically checks for invalidate. Oh, we do have to do this. My bad. I completely forgot. Maybe I want to do this differently though. So basically, the one reason why we need to actually check before we render, or at least the way that Hazel's put together we do, is because resources can actually change kind of behind the scenes. So what can happen, obviously if we explicitly do a set, I mean, we have to handle this anyway, but if we explicitly do a set where we're like, okay, we're actually going to change the texture to be something else in that slot, then it adds it to, it adds it to this input resources thing. It just, it changes the texture in the input resources, which is normally okay. And if we wanted to, we could actually flag it as dirty here and then have it remake that specific one for the next frame or whatever, or for the next, like, whatever. However, for things like a frame buffer, you know, that might get resized, we obviously, the way frame buffers get resized is you create a new one. So it's going to have a brand new handle. The old one's going to get deleted. So what we need to do is basically check to make sure that what we have is actually accurate. And that's what invalidate and update does. Now, it doesn't make sense to do this in all cases. I would probably say that this only needs to be done if this is something called a dynamic resource, right? So if it's a dynamic resource, I would define as a resource that can basically implicitly change, right? So it's not explicit about like, okay, I'm changing this from one thing to another. It's just internally it can resize, like, well, anything that can resize, like a buffer as well. It doesn't have to be an image like a frame buffer. Anything that can resize needs to, like, if it does so, you know, without notifying everyone that cares about it, then those people that care about it have to themselves check. And yeah, I mean, it's not the best thing in the world because it means that you are wasting time every time you render, basically checking to see, hey, has this changed? But it does, I think it's worth it because it's not that much time spent there. Really, it's not anything measurable probably. However, it does give you that, it does reduce the complexity of having to basically have dependencies between like, okay, if this frame buffer gets added to this render pass, then we have to make sure we notify that render pass every time we change. It just kind of, yeah. So it's basically, it's more of a polling rather than an event system, right? So we're not sending an event being like, we've changed. It's just we poll, have you changed? So that's what this does. And I completely forgot about that somehow. Now, it does so specifically with invalidated input resources, which I don't think we need to do. So I think it's going to be a case of, again, I'm going to, and you can see I do have that profile function in there. This is kind of big. I think that whole invalidated system should probably actually work. Like, as in, I think I want to keep it. And the reason why is because, ideally, I think I would mark every single descriptor set with like, you know, is it dynamic or is it not? Sorry, every instance of this class, this descriptor set manager, which I'm probably going to rename to resource manager, every instance of this class will probably be marked like dynamic or not. And if it's not dynamic, then that means you have to tell it that this resource has changed, in which case it doesn't waste time doing this at all. It's because that would be the more common case. Like, for example, materials and objects that get drawn, they do not have frame buffers bound to them usually that can change every time you resize, right? And in those cases, it might be better. So I do want to do that, and I guess we probably should do that, to be completely honest. Like, I don't think we should waste time not doing that, because it will be a waste of time doing it in both ways. But either way, if it is dynamic, then it's actually going to check for invalidated resources by going through and for each of these basically. And for some reason it doesn't check them here. Like that's why the frame index situation is out for some reason. But oh, that's a good point actually. What does it do? Let me just quickly check. Since we have descriptor sets for each frame, I'm guessing it has to create all three of them, right? So we would go through and, because this is going to happen for each frame index, it's just that it does that 3 times. Yeah, that's correct. That's fine. Oh, but I see. So it doesn't have to do all 3 at once. It does them as it goes, which is fair enough. So that means that doesn't exist, which is good. I don't know. I don't know if it's better that way, but whatever. Doesn't matter. I think it has to though, because you can't change one that's in flight. So yeah. All right. Anyway, so getting this is just get handle, and that gives us a what even is it? Just a buffer handle. And so yeah, all we're doing is, I guess we're just checking to see if the handle here matches what we have stored. So because we're trying to retrieve it again. So to check what we have stored, I don't know if we can, because a binding set handle is a binding set, right? So a binding set, does a binding set, like, can I still get, I can get its description, and therefore I can, finding it's gonna be kind of tough though. So I think we do bring back the stored ones or whatever. Because basically we need to check to see inside the yeah, then we basically mark it as invalid. Okay, yeah, this is fine. I kind of like this. This is good. We'll kind of mark it. We'll check to see if it matches what we have set. And to get what we have set, I think we're going to basically have to store that as like binding set handles or something. So we can have, yeah, per frame in flight, and then we'd probably have to, this will be more like a map. So I think we'd have a map of that. Does that work? Yes. So I think they'll both be that. So this is frame to set to binding. I'll call it that for now. But the idea, yeah, and not all of these have to be like this can be up to 3, for example. So I guess it would make more sense to just have a static vector of 3, because that's your max frames in flight that we support anyway. And then that should work the same way. Oh, if we rebake, we probably want to clear it, don't we? Yes. Okay, and then when we go through this, yeah, that's what this stored right descriptor is. So we're just kind of changing it a little bit. So this would be more like binding set map handle map. equals binding set handles at frame index. And then I guess we can do at set as well. That's for the current thing, but how do we insert something into there? Or does that happen earlier? Right, so we pre-allocate it here. Interesting. Guess that's not a bad idea, actually. Maybe I'll do it here. Because we'll kind of shadow this thing. We're basically just making storage for it, but like we're setting it to null pointer. I mean, it'll be that implicitly, but I'll write it explicitly. Probably makes more sense. And then we'll remove that write descriptor map later, but I'll shadow it for now. Now, that means that we don't need any of this. Clearing is still important, I would say. I mean, maybe not. I don't think pre-allocating the map's important. This we don't need to do though, right? Clearing, I'm not sure about. And then we have this here, which is good. And then stored handle, we can say, is this at binding. Yeah, so the thing is we can clear it, but we could also just insert it, you know? Like we could also be like, okay. But I guess that the difference is it's not gonna change unless the whole thing gets invalidated. So I think it's okay. I think let's get rid of this. We'll have stored handle. And then this basically, what do we set this to? Just a binding set handle. Yeah, so this is a resource handle. So if we have a look at like what a texture handle is, I mean, it's all just, I think, a void pointer, but well, let's have a look. It's iTexture, which is an iResource. So it could just be an iResource. So is there such thing as a resource handle? There is. Okay, beautiful. Yeah, this is good. Because yeah, I can just do resource handle and everything else is a subclass, I guess, of that. So, yeah, that's not really a real thing. Yeah, so buffer handle. I want to be explicit with this actually, so I'll just call it handle. And then we'll also do I guess we could, yeah, but that wants a buffer handle. Yeah, we'll just do this. So that kind of, yeah, that does everything we need. And then I'll just continue being explicit with it, I guess. Hey, Walnuts Rule, thank you for the sub. 4 months. Appreciate the support. This is annoying because you can have 32 of these. That's really annoying. I guess this becomes a static vector of 32. Why is that upset? Oh, somehow missed that. Where was that whole max array elements? It's a very long line. And it also ruins everything else because you kind of need to, yeah. Guess we can do stored handles, and we can do resize to input dot size or something, right? No, not that. Because input array, yeah. So we'll just do that. All right, and then once we resize, we can no. Okay, why cannot deduce auto type, really? Oh, because resize returns a void. Okay. We can just do that and then manually change it to that for things that don't support that. But then here, it allows us to do stored handles I equals handle. Some space. Okay, are we good here? I think so. That's it. That's pretty simple. Okay. So now we store them, which is good, I guess, if that works. So here we would look at binding set handles. Which we would actually have up here, I think. So it would be at the current frame index. At this current set, at the current binding, we get a vector, like a... So we get this array. So I think for texture, we're gonna have to go through the array, which, yeah, input.size, yeah. Oops. That's not what I meant. I guess we can, yeah, binding set handle. We'll just do 0. It's still compiling. Okay, stop it. Don't care. So all this does is it says that, okay, the current resource is reporting that you have a different handle to the one that we've assigned on the GPU to that descriptor. So therefore we need to tell the GPU again that it has in fact changed. That's all. Okay, so this is a little bit different because it's uniform buffer set get for the current frame index. I need to worry about the render thread as well at some point. And then if that's changed, I guess we do have to do this per thing, yeah. But yeah, this is also for the current frame index, so that's, I guess that's fine. And then input, because there's an input array, so therefore, sure. And then we just add it to the invalidated input resources, which we'll go through at the end. Storage buffer is very similar. Just says storage buffer. And set is very similar to this. It's just a storage buffer set. Texture 2D changes like a little bit. And it's input I. Yeah, this is strange. I don't even know if we'll ever hit this, so I might even want to set a core verify false here for now, just to see if we ever hit that, because I don't know if we will. So in this case, yeah, we still do handle, but the difference is it's binding set, what is it, handle array at index I, and then we invalidate it. Okay, texture cube. It's probably somewhat similar to this. I'm really wondering what I did with cube textures and if they work, cube maps. What is he doing, chat? I'm working on how resources get set for render passes in the renderer. If that helps. I explained it kind of at the start. Okay, so this is just render a resource, which means we need to do some more stuff, I guess, to get the handle. It's this. Okay, cool. So if there's nothing to do, that's great. Otherwise, we have to go through and apparently do some stuff. Oh, this is so interesting though. Oh yeah. Remember that. Okay, so at this point, yeah, we need to kind of go through and do what we did up here. But this is annoying because I guess we have to recreate that whole binding set. Really? Yeah, I guess so. Because we do it on a per set basis, right? Yeah, so this might not have every set in it, obviously. But for that set, I think we have to go through and do it. Or is it not? Like... No, I guess... Yeah. Because the way that we do it here is... Actually, I should have a look. Because, so we do device create binding set. Is there an update binding set or something? Or are you supposed to recreate that whole thing? I just want to have a look at what this does in Vulkan. Yeah, so generate write descriptor data, and then I'm guessing at the end it just does update descriptor sets or whatever. But what is this? Like, what is it actually storing? Oh, okay. So it's kind of its own thing, but it does contain a descriptor pool, and it contains an allocated descriptor set. Yeah, that's interesting. Sorry, give me a second. Okay, sorry about that. I'm back. Just had a phone call. Where were we? Oh yeah, we're looking at this. Okay, you're right. So, yeah, I don't know what to do about this exactly. Like, as in how to re-update existing things without going too crazy. I guess we just need to remake that one for that current set, basically. So if there's an invalidated input resource, how does that work exactly? Is that just like, that's on a per... So it would be just for a binding, I see. But it's unfortunate that NVRHI doesn't seem to store it in an array. It's just like in a vector, and the binding is stored on the element itself. Is that right? Like, is that... well, yeah, it would have to be, because they don't store... They don't go one level deeper in order to store arrays. So, where was that? So, how would it... So it would just go through the number of descriptor sets, and then probably within there we'd have... Let's see how it does it. That's not it. Actually, look, binding index is in bindings. Huh. So bindings is supposed to be by index. But is that actually right? Or is that just binding index of the array? That's the other thing. We have to have a look at whether or not bind, because I'm sure it uses bind. Yeah, slot is what I'm talking about, see? And yeah, it's got the stupid register offset thing, which I don't like, but whatever. Yeah, so I don't think it actually uses binding index for anything else, does it? No, not for anything that's actually in the render API. Okay, yeah. And it just creates a write descriptor using the slot. It's just my issue is it's gonna, since we're recreating that whole binding set, it's gonna obviously need all the other resources. So it's like we have to recompile it kind of, which because what we used to do in Vulkan is it's just the one that changed. We could change it, and then we already had the rest of the write descriptor sets like ready to go. And so we could just update it, but it would still recreate the whole thing GPU side, but it wouldn't require us to reassemble it. Whereas here we kind of have to, I guess we have to reassemble it or something. I don't know. Yeah, it's kind of like we have to go through this again. I mean, what this does is it just marks the ones that are invalidated, but I feel like we actually have to go through and recreate it here, actually. It's almost, we basically have to rebake it, honestly. I guess this is not bad because it identifies whether or not we have to rebake it, and it tells us what needs changing, but at this point, it's like, you rebake it. So I guess that's what we'll do, because otherwise I don't really, you know. I guess we just bake it again. I don't know if buffer sets is important here, but whatever. Yeah, in which case I don't think we need to do this either, because we just, or do we? App binding. Yeah, because it's just a map, so we reset it. Okay, whatever. Yeah, and let me just make sure that we, yeah, so stored handles resize to the input size. And I think we just override everything, so it really shouldn't matter. But yeah, if it's not empty, we'll basically bake. So that's what we've changed it to, which is a bit interesting. I want to grab the, it does seem very simple, but I'm slightly worried about performance. But hopefully this will not be a common case. We have to make it a bit better, I think, and mark these certain instances of this manager as dynamic or not, I think. But I do want to do this. Don't really care about the set. I just want some basic logging to see how often we hit this. Okay, how's descriptor sets? I guess that's binding sets now. I don't know why we need this. Don't really care about this. This has all just been changed to binding sets. Okay. We've got a few errors now. Where's this one? I can't see it. Oh, here. Okay, so it's not happy that I'm binding this to null, probably because it's an array now. Oh, and also creating it up front was not really. I don't think we need this, so we will probably get back to it. Okay, I feel like this is basically compiling. Okay, let me get rid of Vulkan. I mean, we probably need Vulkan shader actually, but I'll get rid of this Vulkan. The other one probably includes it, and we'll make sure we don't have any like VK. Oh, well, yeah, it's compatible input, and forgot about all that stuff. We still check all of this stuff in validate, I guess. Yeah, so validate. Let's do that now. So we've got our shaded descriptor sets. Oh yeah, and we've got all this right descriptor stuff. So I'm gonna get rid of wherever we were storing this like right descriptor and yeah, so this I'm gonna get rid of. We'll see what errors that creates. I think we're still keeping it around, even though we don't use it. It's not much, to be honest. Yeah, that's what this was basically trying to do, but I don't think we need it. Yeah, so a render pass input. So we actually has a type here, and we're converting it from this right descriptor, shaded descriptor, right descriptors, which we don't really need. It's just we used to go through this list of them here. I wonder if we could, maybe we could just convert this to immediately be binding the right type even of binding. So we don't need to. Because what's the point of this? We just have an input declaration and we check to see what if it's the right type. We're gonna pass input declaration. Yeah, but it's worrying that we have to iterate through this. Like, we don't really have a list. We probably should just create this almost in the shader system. Because we don't, inside there we have right descriptors. But otherwise we have all of these things. And it's like, well... and we used to, in Vulkan shader, I think this is, yeah, create descriptors is where we create all of these. Yeah, but we also do the binding layout items, but where are those stored? And we go through all of these things and create that. So this is where I think we used to also, in the old system, we used to also create the right descriptors, is that right? Or not? Oh wow, there's a lot of functions here. Maybe not, we're not, doesn't look like we're creating them here. So where did they used to get created? Ah, yes, it is here. Yeah, so I think we can do this. It's just that it should probably be, yeah, I think this will work well. It's just that at the moment we're literally just doing the binding layout, but since we're going through all of them here, and this is like our shader reflection kind of system, I think we should just be able to kind of create a render pass input declaration, basically. I don't know if it should be render pass though, because remember we wanted to potentially rename this. I think it should be like a shader resource input declaration or something. That would make sense, right? Or just a render input declaration. Render input declaration. That sounds nice, I think. But basically this is what we take. And then we make it happen here. So for uniform buffers, we can do, so we'll move this to, at the moment, Vulkan shader, because we're still kind of tied to Vulkan here. Or maybe Vulkan shader resource. I'll call it render input declaration. Yeah, we'll take all of these. Oh, maybe that as well. Although the input, I think, actually should be here. And we'll get rid of pass, just render input. Okay, so we've got all of these now. Yeah, this, I don't know about that, but whatever. Yeah, and so instead of write descriptor sets, we'll basically have, it says a map of string to that. Is there a reason for that? Just decided to. I don't know, it's weird. Why is this not? Should all be included. What? It's a bit strange. Oh, namespace shader resource. I don't think we'll need some of that stuff there. Okay, back to here. So render input declaration, and we can do, I guess we can just do input declarations like that. Yeah, so by name, interestingly. So how did it even, I guess we want it by name in a way. Whatever, we'll keep it like that because that's how it is. But how does the name work? How did we used to make it by name? Where did we get the name from? Uniform buffer.name. So it should just be an uniform buffer.name. Like that. Now this we just don't really need to convert at all. It's just render, I mean, what is it anyway? Render input type. Uniform buffer. And count. Size is probably the size in bytes. Maybe there is no count for this. Okay, why are you upset? Is that const? Not anymore. Yeah, so I guess, yeah, this is, I'm guessing we just do this basically for all of them. Image sampler, like what the heck's that? Could be any of these though. Do we really not have any? Oh no, we will. We'll know the dimension, I think. So, There's array size as well, which is what I was looking for. Okay, cool. We probably need to set that here though. Get array size 1 or size. So I'm guessing this is descriptor array size. It's a good catch, I think. Separate textures. Oof. What do we do here? Kind of seems like the same thing. Interestingly. And separate samplers. I mean, this is a sampler specifically, but we don't have input as a sampler. It's still image sampler, so don't really know what to do there. We'll just change it to sampler as well, I guess. That's still gonna have a size, I think. Okay, and then yeah, finally storage images. Unordered access, sure. I think it's the same. Except do we support count for that? Well, yeah, why not? And this is a storage image. Cool, I guess. I don't know. We'll see when we run it. But the benefit of this now is we know, I guess, the types and everything, so we don't have to try and do this stuff here. We just go through the input declarations, and we've kind of already got them, like render pass input. Yeah, so we still need to create these, but we already have that input declaration. That's what this is. I don't know what bname means. Oh, broken name. Hack to fix bad input. Okay, interesting. I think I might know about that, but anyway, whatever. We clearly need binding, so binding is input decl.binding. This we can delete. True, I guess. This is all render input type. But the point is we have the declaration, so we don't need to make the declaration. And what the heck's this? We don't need to do this, we've already done this. Okay, so that's easy, yeah. Just do a little find replace. Lots of errors here. Well, we don't really, I don't think we need this. So get default resource type. What's that used for? Oh yeah, here. Render pass input. But why would we need to do that? So for both of these, it's just that. No, I mean, I kind of see that. It's just not going to be that. It's going to be... But so it's going to probably take in a render input type. And give back a resource type. And so image sampler or image would be... Fan of Cherno, thanks for the sub. 39 months. Appreciate the support. Thank you. Yeah, I don't know how important this is. We'll see if this ever gets hit anyway. I'll just translate it for now, but... But yeah, we'll see. Okay, validate. Yeah, that's where we're up to. So, yeah, the difference is we have an input decal instead, I guess. We probably should make to strings for this. That's kind of it. Oh yeah, it's compatible input. I'll call this input a resource. Okay, does this ever get used? No. delete this. So we're getting rid of all that Vulkan stuff, which is good. Yeah, let's have a look at this. All right, cool. So it kind of compiles now, which is good. Okay, this is seems to have been mentioned as a class somewhere else, so we can fix that up. All right, cool. Yeah, I mean, this kind of maybe will work now. I mean, so the way that we're going to debug this is basically, I think we can just run this now. Like, as in, because validate used to return true. So now that we have added in all this functionality and changed everything. Well, first of all, let's give the engine a compile, see if it works. But second of all, inside our scene renderer, we're obviously going through all the code that creates all of these, and it's got inputs and it's trying to validate them. So we should be able to, like, you know, when we do these core verifies and it tries to validate the render pass, which will in turn call validate on that descriptor set manager, which is our render resource manager, it will tell us if it's right or wrong. And if it's wrong, it means that we've done something wrong, because obviously this code hasn't changed. It means that maybe it's not correctly aware of what a type should be or whatever. So this is going to be a really good test, I think. Okay, so we've got some issues here. Yeah, this is just changed names. Okay, so how do we know if it's baked or not? So if it's got a descriptor pool. Oh, there's all this stuff as well. So yeah, so I guess there is this, is there a, but we call get descriptor pool, okay. Just wondering if we can, if we, how do we know if it exists or not? Binding set handles, when did those get set? Initially up here. Why do we need to know if it's baked? Where is that used? I don't think that's used anywhere. Is it? Oh, and this is still a Vulkan render pass, by the way. Yeah, baked is not used anywhere. So I say we get rid of baked. Okay, and everything else. So we can do this, right? Inaccessible. Ah, let's do public. That should work as long as it's not public or whatever. There is get descriptor sets, which we still call that. We call it get binding sets. And that, what does that return? Yeah. I mean, that, where's that used? Oh, in Vulkan renderer, sure. So we're gonna change it to get binding sets. And it's just gonna, I guess it'll just get it from here. It'll just be a vector of binding set handle. And we can just do return descriptor set manager, get binding sets frame index. And this goes away. Sure. I don't know why it really needs all this, but okay. We might revisit this design a bit later because I'm a bit suspicious about it. Now this is gonna trigger a bunch of errors probably here. Actually, I don't know if we'll hit it. Let's just build everything. I'll be back soon. Oh, errors. No, I can't go anywhere. There are errors. Ah, yeah, this stuff. Yeah, baked. Same kind of story, I guess, for compute passes. Yeah, this I don't, yeah, okay. It's very similar, I guess. Okay, we're gonna rewrite some of this stuff. I will BRB. Okay, I'm back. What I want to do with this is get rid of this like subclass situation, right? So we still have compute pass and Vulkan compute pass, whereas we don't need this. We can just have one. And same with render pass. We have Vulkan render pass and render pass. And that obviously doesn't need to exist anymore because we are using NVRHI. So and this does not need to be Vulkan specific. So let's rewrite, I guess, this. Most of this is virtual stuff anyway, but I'm gonna grab, I guess, this and replace it here. And then we're going to get rid of all the virtual stuff and all the overrides. And then if we go to here, we'll grab this, pop it in here. Change that. Just make sure that we probably don't need to include much of this. It's still in Vulkan, isn't it? That descriptor set manager, so we'll probably move that out. Has buffer sets just not implemented and doesn't seem to be needed. Okay, cool. And then we'll still we'll move this stuff down here. And have a static ref compute pass create. Okay, cool. Make sure this compiles. And that's weird. No, because this includes renderer. But why does it not know what compute pass is? It does include compute pass. Does that include the renderer? Hopefully not, but maybe. Do we need to include the Descriptor Set Manager here? Oh, well, yeah, because we make it here. But why does compute pass? Yeah. I mean, maybe it doesn't need that. Yep. Okay, and now we do the same thing for render pass. They don't really do that much stuff, to be honest, these classes. But they still need to exist, I guess, because they do a little bit. Wow. Did not mean to do that. All right, let's try another build. Oh, yeah. So Vulkan render pass and Vulkan compute pass are now deleted. Stop building. Delete. Still quite a lot of stuff though. Oh yeah, we gotta fix up all that. Oof, this is gonna change the way we serialize this stuff as well. Does this really need to? Oh yeah, I guess it's because it's cached. So this is input declarations. Oh, but it's all actually it's fine, I think, because it's all render input declaration. It's all just a pod, so no worries there. We just have to make sure we delete all of our shaders. So, what? That shouldn't need that. That's odd. Oh, it's got a string. That's why. Okay. That's okay. Just it needs one of these because of the string. Okay. All right, so we build everything. Oh wait, did I already delete it? Gotta delete this. So this is gonna take a while because it's gonna recompile all the shaders from scratch and recache them. So we'll have a look at what this says and stuff. And whether or not it crashes. Oh, wait, it couldn't have done all the shaders again, right? That was really quick. Did it? Wow, that is fast. Okay, so apparently resources null camera. What? Okay, well this is what we expected. This is good. So let's have a look. So in Quad Pass, we have a Descriptor Set Manager, which has one input resource, it seems. Uniform buffer. But what about the input declarations? There's 0. I guess because they're in the shader now. Maybe that's why. So these input declarations, right? What are they used for? Yeah, but I don't think we need them. It should just be like coming in from the shader, I think. They're stored now in the shader, actually. So I think we just, but we have to get the shader. But that's all right, right? We have the shader. Or does it need to be like some Vulkan shader? At the moment, for now, yes, but that will change. So this should work. How do we get the... Oh, and it's inside shader descriptor. Sets. Input, yeah, for a particular set. So what is this input valid for at all? I guess it has to find the set. Ah, so that's one thing that I guess was different. These input declarations used to just be setless. Whereas these are per set, which is fine, I guess. Have to set them each as well. What's this in? This is invalidate. So we can try this. Let's try and build that and run that. All right. Probably gonna wind down the stream soon. Okay, so Bake is not happy because binding set handles now. Oh, that's weird. Why would that have changed? A frame index 0 set 1, and it's what? It's not there, it's 0. Oh, or is it this? Binding set frame index, no. Yeah, it's map, it's the map. So the map's upset because we don't have set 1 in there, but we do, it's here. Oh, inside there we don't have the set. Ah, that's because I removed this, isn't it? Why did I remove that? Oh, because now it's an array. How did that work the first time? Oh, I think we just got further. Okay, yeah, so that other thing did work. Because now we're initializing... We're still in render 2D, though. Oh, because we got past validate now, so we're in bake. Got it. Yeah, so... I guess, yeah, we have to make this work. So... Because this is now an array. Do I know how many items there are there? Input decal count. But I'm not in placing back later, am I? Probably not. Yeah, we've already got the right size, so that should mean that in bake for images, I am... What's that even for? The stored things, right? Yeah, so it already expects I there. That's from here, which is binding set handles, which is what I just did. Okay, great. So that should in fact work now, hopefully. Okay, frame index and set 1. It says 0, we seem to have something. But we're in set 1. Oh, we just do binding sets in place back. That's a bit weird. Why do we do that? But also, wait, hang on. How can this not work though? Oh, this is a vector of vectors binding sets. Oh, I see. Yeah, okay. So this doesn't work if, because it's not a map, it's a vector. What do we even use that for? Well, I guess we get it later and we use it for rendering. Yeah, so we in place all of these things, and then I think we should also go. So at the moment, it's going to try and go through every set and clear it, which is fine. And it should have one per frame in flight, but we should also make sure that we have the right set here. So this actually has to do this. If binding sets frame index dot size, that's the thing, right? Is less than or equal to the set. I guess I just rather do a yeah, I guess we just do a resize to set +1 or something. Right? Whoops. Will that work? So the size at the moment is, well, it would be 0 and we're in set 1. 0 is less than 1, so we'll resize it to set 1 + 2, so we have 2 in there, and then we can address it properly. That seems like it should work. Oops. I hate this. I feel like this maybe should happen in init, but yeah, we'll see. Because that's obviously a memory allocation. Yeah, I might move that to init. Okay, so now we're trying to update descriptor sets, and it's not working for some reason. And why is that? We seem to have everything. That's weird. It doesn't really tell us why. Set 2. Oh wow, this has a bunch of stuff. What is this? What is this render pass or whatever? Maybe some material. No, it's probably a render pass. It's the directional shadow map. Okay, yeah, I guess that's got a bunch of stuff. So the binding layout looks legit. It's just got a structured buffer, apparently. Don't even remember creating those as a binding. And this is a raw buffer. Okay, so the binding layout comes from here. There's no way that, that's a vector, right? Yes. What is it exactly? Like, what are we trying to set here? Bone transforms. A raw buffer UAV, but in the binding layout it's that. So bone transforms would be a storage buffer, right? So it's coming back as structured buffer SRV. Which I don't really know what the difference is. That's our shadow map. But hang on, shouldn't it be? Yeah, that's probably the shader itself is probably different. Yeah, it's the animated one. Which uses our bone transforms inside buffers, probably. Yeah, which is I mean, that could be a struct. There is basically a structured buffer. I don't know though. Let's just make this a raw buffer with unwanted access. We'll see if that fixes it. Oh, sorry. Actually, that's wrong because this but it's not. Wait, it's not a storage buffer though. It's a read-only buffer. So that'll be an SRV. How do I know if it's read-only or not? So 3D was coming up. I mean, that did work, but what? Texture cube. There's, yeah, a bit of a difference, but whatever. 3 dimensions anyway. So, yeah, I wonder if, I wonder how that gets picked up in here. Oh, it's even got this stuff here. Yeah, lol. But anyway, that'll be in the reflection. Whatever, we'll get back to that later. That's not technically correct, though. Yeah, I really would like to know if things are read-only or not. But whatever. Walnuts Rule asked a while ago, I just noticed, sorry. How many hours a week do you think you work on Hazel? It's just during these live streams. So, depends how long I stream, obviously, but like, I mean, this week is probably like 3 to 4 hours because I didn't do a stream on Monday, but otherwise it's double that, so 6 to 8 hours a week. So not like a terribly long time. During like intensive periods when we're trying to get stuff shipped, I usually buckle down and do a lot more. I don't even think we have a texture 1D. What's asking for this? Like, which render pass is this? Geometry pass. Type none. Okay, that seems a bit incorrect. All right, from input declaration. What's it called? Shadow map texture. Shadow map texture. Why is that one dimension? That's very strange. What? It'll be in like PBR resources or something. Shadow map texture, sampler 2D array. But it thinks it's a 1D texture? What? Count 1 as well. Because it's, well, actually it is 1, because this is just it's a layered texture. So, but I'm just not sure why it's coming in as a one-dimensional thing. So what sets that to be a sampler 1D? Because that would happen in where, like, Vulkan shader compiler. It should only happen if it's, like, it should still have 2 dimensions. That is just very weird. Spot shadow texture also got image sampler 1D. Spot shadow texture. Is that also... No, that's just a normal sampler 2D. What on earth? Why did it give them that? I mean, I don't know. Maybe I just nuke this again, the cache. But that, yeah, is a bit weird. Because it clearly seems to look at the dimension and set it otherwise. Unless I did something weird somewhere. Which is possible. Yeah, so again, we're kind of in this 1D land for the shadow map texture. That is super strange. We're gonna have to put some breakpoints here, I think. And see how we hit this. Assuming it is even coming here. Okay, look, that was quick. What's the name? Texture 0. What shader is this? I am gooey. Why is it dimension 1? It's not. That's so weird. Where is this coming from? Separate textures, image sampler, dimension. But like, I'm guessing the shader compiler. Yeah, dimension, base image, dimension. So weird. 1D, 2D. Oh, what? That's really weird. How did the rest of this work? Because look, this dimension, yeah, if it's 1D, it's actually 0. So it's coming in as 2D because it thinks it's 1, but we think that means it's 1D. That's what's happening. But I don't understand why we're just doing that instead of translating it to something else. Because if we do this, then obviously you need to do something a bit better than that. That's a bit weird. How that was never an issue before, or what? I guess we didn't actually use it before. Now we're using it to determine the type. That's what's changed. Now we're definitely gonna have to rebuild that. Okay, we're still hitting this somehow. What? That's odd. Does that mean we're hitting this? Because this is a texture 2D. So that doesn't make sense. And I did delete this. That's very weird. Yeah, we are hitting this. Oh, no, sorry, we're not hitting it. What? What? I did put a breakpoint there, right? Just then. Yeah, I do have a breakpoint here. What on earth? Oh, that's just for sampled images. Ugh, we've got to do this everywhere. My mistake. What was it here? Type image. Okay. Okay. What? What is going on? I mean, sure, leave that here, but separate samplers. Here it is. It should be getting the dimension from here now. That's not gonna run again. Unless I didn't delete it properly, but I'm pretty sure I did. Okay, look, it is here. It is dim 1D. Oh, no, wait. Yeah. What? How? They're just all 0. It's like, it's clearly not reading it correctly. Oh, because it's a sampler. This is a sampler. Why are we looking at the dimension of a sampler? Oh, well, I know, actually, that's valid. Samplers have dimensions, right? Well, actually, not ones in HLSL like that. Because this is just sampler. So maybe we shouldn't do this, because then that translates to us having a separate sampler that it thinks is 1D. Well, for now this actually might work, but in general, it's not good. Because we don't, for that particular texture, we actually don't care really. Like, we don't go through that descriptor set manager system. Okay. Input type none. None. What resource is this? Environment in radiance texture. That's a cube map. Why is that coming up as none? That should be a 3D thing. Well, actually, I mean, it might be, yeah, might be 2D with, yeah, but that's still something. So where would that happen? That would be in none. How do you even get none? Oh, if it's I guess if it's none of these. Because here we set it directly. Let me just do this everywhere. Just to detect when it's happening. Well, it's hailing outside. Oh, here we go. Oh, okay. No, this is dimension 1. Oh, yeah. We decided to skip that for now. Okay, so here we go. So this is this correct? Yes. So what does it think the dimension is? It's 0. How could that have happened? And it's an image sampler. Dimension 0. So that would be what, here? I mean, we set it to whatever it is, but it must... Oh, maybe it's a different... What are the other options? Ah, there's a cube. And it's also 3. That's why. That's a bit sus, but... whatever. Okay, we're still in dimension 0 land. For output texture of which shader? Environment MIP filter. Output texture. Oh. So it's an image cube with a whole bunch of stuff. Well, it should have... Oh, but it's an output. Ugh, I did that stupid thing again where I didn't do this everywhere. I've got to do this everywhere. Okay, update descriptor set. This is upset now. Maybe this is an example of one of the things that isn't set. I guess we can have a look here. He's got no sampler, but it does have an image view. Does it need a sampler? Maybe that's the issue, one of the issues. But how would it set its sampler? It never sets it. Does it always want separate samplers? Yeah, that's a bit annoying. I wonder if that's the issue though, but it's annoying that Vulkan doesn't just tell me what the issue is. Sorry, I'll be back in a second. Okay, sorry about that, I'm back. Yeah, alright, so this whole situation is a little bit annoying because, I mean, the way that it's set up is that it always separates samplers from textures, right? It seems, just by looking at this, because when they create the image infos over here inside the Vulkan backend, they only ever set, so an image info in Vulkan has basically three things in it. It's got a layout, an actual image view, and a sampler. The sampler can be null if you've allowed for that, if you're saying that it's not a combined image sampler kind of type. But you can see that, for example, if it's a normal texture, SRV, which is what this is, a read-only texture, that's in shader read-only optimal, then you can see it only ever sets the image view and the image layout, and it leaves the sampler null. And the only thing that sets the sampler is the sampler. So I guess it's kind of made that way to mimic HLSL and DirectX a bit more, because, for example, in our I'm GUI shader, you can see that there's a sampler and there's a texture, and they're separate, and the texture does not kind of include the sampler. So I don't know, like, I guess we probably should do something like this. Now, realistically, textures don't really need to each have their own sampler. It's usually okay to use like a group of different samplers with any texture. So you would have one, for example, for linear filtering. You'd have one for nearest filtering or point filtering. You'd have one for various wrap modes like repeat, like for tiling or clamp. And then you might have ones that restrict like what LODs, what MIP levels you can actually access if you need to. And that's more of like a specialized case. So I'm not terribly opposed, I guess, to doing that, to just separating these out. Now, in Vulkan though, I mean, clearly this must work. I've never done this way in Vulkan. I know you can set up immutable samplers that are actually part of like the pipeline layout and stuff. But this looks like just a sampler with no image, and I don't really know how that would translate to GLSL, for example. And if you'd have to use something special for that. And that would probably, if we go to like resources, right? PBR resources, like for all of these things, you can see they're all just samplers, and these are basically all combined image samplers. That's how we do this in Hazel. So when we set each of these resources, they all have the image info, the Vulkan image info would all have a sampler, an image view, and an image layout for them. So yeah, I don't know. We did potentially want to convert this to HLSL, but that's also quite a lot of work. And that, in my mind, that was like phase 2 kind of thing. So we'll have to think about it. That's why I'm assuming this is upset, but also I guess it can't be upset because of that. Unless I guess Vulkan internally is expecting an image sampler and it's not getting one. Maybe it's not that. I don't know. But we are trying to do update descriptor sets, and like the only real problem I'm seeing is that we have a image info with a null sampler. But again, that's usually permissible, but maybe you have to tell it that it is. Maybe you have to not create it with... I have to probably Google this. That's immutable. This is all like immutable sampler stuff. But these aren't immutable samplers, so... Anyway, I think this will probably be a good place to stop, and we can. I'll think about this a bit more, and then next time we stream, we'll get on this. But yeah, I mean, we're not doing too badly now. I think we're getting through like all of this stuff, and the main thing is we rewrote this descriptor set manager today, which I was really keen to do, and it's mostly working. There are some types like, you know, UAV versus SRV that we probably have to deal with so that we can properly have like, you know, read-only buffers, read-only storage buffers versus write storage buffers and stuff like that. But we will, yeah, get to them one day. So thank you guys for watching. Hope you enjoyed the stream. Don't forget, patreon.com/thecherno is the best way to help support Hazel and get access to all the source code and everything. Also on YouTube, on my Cherno Unplugged channel, is where I post all these streams. So if you want to follow along, or if you're lost, then definitely check that out. Thank you guys for watching. I will see you next time. Goodbye.